Start recording. All right. So, as you all have, right, we at least have a very basic AI, but while great, if you're doing something super simple, right, perfectly good. You don't need to go crazy, right? But if you want to do something more, you want to have an AI that feels like it's actually doing something rather than just 100% following along with the rules. We want to actually break away from that and move into behavior trees. So that's what we're going to hit today. So what we're going to do is in our enemies folder, under the blueprints, we're going to actually go ahead and add into here an AI folder. So left click, right click, new folder, just call it AI. That way we can put all of our AI related things there. For this, we're going to be doing behavior trees. So we've got our AI folder, and into this, we're going to add our behavior tree. So we're going to right click, and then under artificial intelligence, we've got the behavior tree. So we can just click on that. And we'll call it, surprise, surprise, BT enemy base. Type it right, that'll help. And then a behavior tree, while is great, a behavior tree doesn't run without a blackboard being attached to it. So you can think of the behavior tree as the decision-making process of your AI. So it's like the thought processes that are happening, whereas the blackboard is kind of the brain, right? So the blackboard is where we're going to store our variables that we'll interact with, that decisions will be made off of, but it's going to store it there. So behavior tree, decisions, blackboard, brain, data storage. So we're going to then add in, we can right click again, artificial intelligence, click on a blackboard, and then we'll just, surprise, surprise, BB underscore enemy base. So now that sets up everything for us. We're going to go ahead and double click just on the behavior tree. So we can crack that open. Bless you. When we go into our behavior tree for the first time, you're going to see your root. So this is basically the start of everything, right? Everything's going to come off of here. And you notice that it's listed automatically with BB enemy base, right? So our blackboard is automatically attached. When you just have one, you don't have to attach it together. If you created another behavior tree and another blackboard, you're going to actually have to connect the two and pair them together. We thankfully don't have to worry about that. And so we could technically open our Blackboard, but we don't have to with this because we have the ability up here in the upper right to just switch between the Blackboard and the behavior tree. So we're easily able to access both of them. So we're just going to save a window and keep it like this. Let's see. So behavior trees have two main components, which are, if you drag off of the little glowing button drag point onto here, we have selectors and sequences. So a selector is going to, well, I'll just drag them both out for fun. A selector is going to make a choice between usually one of two things or one of a couple things, right? It's choosing between different tasks that can be done, and tasks then fall under each of these. But it's going to do one. All right, the selector is going to just see, it's going to find the first one. It all processes left to right. So whatever is furthest, whatever task you might have assigned, so we can drag off a task like move to, and a task wait, or set tag cooldown, since I grabbed the wrong one. We can do a wait over here, right? We have access to all these. We can do these also in a sequence, but a selector is going to find the first one that works of the list there, once again moving left to right, and is just going to do the one. Once it returns one, once it finds one that it'll do, it's done. It's good. Yay! It solved its problems, right? That could go all the way to the wait and then having it go again, right? The sequence, though, is going to be a series of tasks, right? So a sequence could be, and we'll use this obviously we go, draw, if you see the enemy, or if you see the player, draw your sword, charge at the player, stop at the stopping point, move into your attack sequence, maybe do a special attack if you could go into like special attacks from there, if they have enough I don't know, sword points, I don't know, whatever your sword magic system is, to do it, and then wait for a cooldown based off of that, right? So it's going to do the whole thing. So the sequence has to do the whole bit for it to actually run. Selector does not. All right. Perfect. So I'm going to delete these ones because we don't need those ones. We are going to first start by just recreating what our previous super simple AI could do, right? We want to duplicate that. We're going to switch it over to the behavior tree. So we're going to, from the root, we're going to drag off the sequence, or I'm just going to leave the sequence. I'm going to delete the selector for now. And from our sequence, like we had just shown, drag off a move to, right? So that's what our enemy is doing, our AI is doing currently, right? It's moving to you and shooting at you. Those are the two things that it's doing. So now we're not just moving. Currently, we're not just moving our AI to a random spot, right? The idea is the AI knows where the player is, and it's going to track it down and attempt to kill you, right? That's its main goal in life. And so we need to get a reference to our player character, right? Our AI needs to know who that player character is. And so we do that once again through the brain, which is the blackboard. So if we click over to our blackboard, you'll notice that we have keys here, new keys that can be added that are booleans, floats, integers, names, objects, right? We can say what that key is. And the key is then what the AI is going to use and pull the information to make those decisions about. So what we're going to do is we have one key that just automatically comes with it, which is the self factor, right? So this is going to be a reference to the AI itself, but we need the reference to our player. So what we'll do is we'll click on new key. We're going to select the object type of a key, and we can rename this to attack target. Not with caps. Right, so this is who the AI should be attacking. And then we can select it, and then we have another details menu, basically. This is specifically connected to a blackboard. And so what we're going to want to do is in the drop-down key type, we're going to set the base class. So we're going to open up key type so we can see down there. Base class just says object. We actually want this to be actor. So either you can type in actor to lower the list, or you could have scrolled down just a bit and it was there. So now that is stating that for the target of the attack, that is going to be no matter what of the class actor, which is great because that's what we have it set up as. So we can go ahead. There is no compile on the Blackboard. You're just saving data. So we can just go ahead and click the save button and then go back to our behavior tree. And then if we click on our move to, this gives us a whole bunch of other details. If we look under Blackboard, it's currently the Blackboard key is set to the self actor. So right, that is setting it to technically moving to itself, which is kind of a weird thing. I don't know, maybe it could like have split personality and it's like, oh, I'm over there actually. That's not what we're going for. So we're actually just going to go ahead and switch this to our attack target. So you'll switch it in the details and you'll notice here on, I can't zoom in anymore, but on our move to, it is specifically saying move to attack target. So it's making it clear where exactly this move to is going to be. All right. And then as we've done before, in the details for this, it's set up very much like the move to node in Blueprints. We have an acceptable radius. So we're going to actually switch this to, let's drop this down to 500. I know we did 750 previously, but sometimes it's hard to kind of get it to chase after you quickly and easily. So we're just going to change, bless you, on the node, acceptable radius, we're going to set that to 500. All right, and then we can end up actually with this. Move to is great, right? It's descriptive-ish. It's telling you that the action that it's going to try and do is move from its position to something else, right? That could be to the player, to the fire. If you do something, it's like, I wave my wand of kill yourself at you and you walk to the fire and drag the barrel with you because I'm a real meaty pants, right? Whatever that is. At a certain point, though, this behavior tree, when you get more and more complicated, becomes a little overwhelmed with a lot of different nodes in here, a lot of tasks that you're going to add. These aren't going to just be the ones that are built in. We're going to create a bunch of nodes and tasks ourselves. So what we can actually do to make it a little bit easier to read what's going on is here in the details and description, we can set it to move to target. And then you'll see in our behavior tree, it then sets that as the description. So now we can be like, oh, okay, I know really quickly and easily as I'm scanning, that's exactly what it's doing. All right, so we now have an AI, technically, right? It's got a task. It's got something to do, which is just move at this moment in time. So we can actually now connect this to our AI character. So we're just going to hit save to save our behavior tree. And then we're going to open up our BP in our third person blueprints, our BP third person. Oh, no, wait, hold on. Nope, that's the wrong one. Just kidding. We want our BP enemy base. So in blueprints enemies, we want the BP enemy base. Right? This is who the player, or this was got our original code, right? The chase player should have our attack in here. Yep, we've got our attack. And we also have our health depleted, tracking that. So if we scroll down to just above events and the details, which we're going to probably just want to click and drag down here. You'll find the pawn section. And so in the pawn section this is where we connect to the AI controller class, which is great. This is the general AI controller class. So this is where we would end up putting it, but we don't have an AI controller class yet. So let's go ahead and take care of that. So we're going to pause here for a moment. We're going to go back into our AI folder. And we'll go ahead and right click. We're going to create a blueprint class. And then we're going to go ahead and drop down our alt classes. And we can start typing in AI controller, which will show up under object actor controller, AI controller. And that's the one we're going to want. So we'll select that one. And we're going to rename this one AIC for AI controller. And then once again, enemy base. No, just AI controller.
Well, I'm clicking on it, but that's...
So if you come in AI controller, it should be this one here that just is literally just under controller. If you started typing in AI controller.
Yeah, I did, but that option's not showing up. I only have 2.
That's fabulous. How far into AI controller did you get typing? Just type AIC.
Well, yeah, that's the job. That's the stuff. Specific ones. Industrial issues.
And then AIC underscore base or NV base. All right, cancel this. All right, so we'll go ahead and like usual, we're going to double click on the AIC enemy base. So we get to our controller. We're going to go to the event graph. We're going to remove the events that are currently here. We don't need them. Yep, AIC enemy base. Into the events graph, delete the current events. We're not going to use them.
Also, real quick for the enemy base one in pawn, you said like which one?
None of them yet. We were just showing where we're going to be working.
Okay, just fine.
Yep, no, you're good. And so what we're going to do for this, though, we're going to right click and we're going to add event. If I can type today, event on possess. So what this basically does is when basically the AI controller is going to possess or take control over a pawn, right? So we can set up any pawn. Apparently they like the symbolism of possessing. I'm not really sure. Either very possessive or like a good amount of good ghost stories, right? So that's what we're gonna do. And we're going to just drag off of our execute, and we're gonna type in run behavior tree. We're gonna add that. And then surprise, surprise, when it asks for the BT asset, that's gonna be our BT enemy base. Ding, 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 amazing. So while is more that could go into here, this is really all we need to get our AI to just pay attention to its behavior tree, right? We've set it up. We've said, hey, as soon as you become possessed, right, you should now act like this behavior tree. So we can compile and save. Give everybody just a minute to catch up.
Are you gonna do or ignore the behavior we programmed last week?
We're going to delete it for the most part, except for the act, or except for the attack. The move to will go away. All right, so this is basically it that we need for the AI controller enemy base. So I'm just going to close it for now because we're going to have a bunch of windows open. And so now if we come back, let's see. Oh, wait a minute. Hold on a second. If we go back to our I believe it's here. Let's see. Make sure I'm in the right section. Hold on. Do I actually want us to stay there? Let's go back to the AI, see the AI controller enemy base. I really need to find enough time to rerun through my notes after I do this. So we can access our behavior tree nodes, right? At some point, we're going to want to send stuff to and from the Blackboard, right? Because that's where the brain is kept. So if under our My Blueprints, we've got the gear, and we can click on the Show Inherited Variables. And then if we open up our variables, now we have a whole bunch of variables that are tied to and connected to our Blackboard, right? So now we have actually our Blackboard here. So now we can start playing with our Blackboard if we needed to. Let's see. So if we drag off Blackboard, I'm going to trust that I'm right on this. We can get a copy, a reference to our Blackboard. And then we can drag off of our Blackboard, set value as object. That's the one we're going to want. Yeah, this is right. Perfect. We're going to connect this to our run behavior tree. So that's going to run after that. We're going to promote the key name to a variable. So right click on key name. That gives us our promote to variable. We'll go ahead and rename this to attack target key name. Because the longer the variable name, the more reading I have to do. I'm not sure. I do like to use highly descriptive variable names because while X2, potato all work, like I'm never going to remember what that is. And if I can have a nice descriptive variable name, I am supportive of those. Um, so while we have it, we need to compile before we have access to set a default value, which we're going to want to do. We want to now set this to, I'm going to come back here to our Blackboard. It needs to be named exactly the same way that your key is named, right? So if you don't trust your typing, like I usually don't trust mine, you can come back to your Blackboard, copy its name, and come back and paste it into your details. If you do trust your typing, type in attack target, right? Exactly like you had on your Blackboard. And then we can drag off of object value, right? So what object is that going to be? And for this, we want to get player character. Right, so that's who the AI should be targeting, right? We're now telling it, hey, by the way, we've already told you that you should be going after the attack target, and it's like, I don't know who the attack target is. Well, now I just told you. We've now set it to the player character, right? So this could be, the attack target could be the barrel. The attack target could be the fire. It could be something else, right? So we've now told it and said, hey, this is truly what it is you should be attacking. All right. So the other thing that is kind of an interesting one is that on possess actually happens before any event begin plays. So in the order of events, when everything's loading up, on possess will happen before event begin plays will happen, which is great to know, except in situations where technically our character, our get player character, is not actually added to the game until begin play. So we need to actually put in a small wait here. So between our event on possess, we'll drag off a delay, which automatically connects it for us. And we can just leave it at that 0.2 duration. It does not need to be much time at all. It happens relatively quickly, but we need the actual player character to spawn and be brought into the game before we can say, hey, go attack that. All right, we can compile and save. Now if we go back to our BP enemy base, now where we were before, right, the details under pawn, in the AI controller class, we want to now set this to our AIC underscore enemy base. So we have to create that controller first for us to be able to say, hey, this is who you are now. Yeah. Yeah. Let's see. So if you come to, so this one, so attached to the variable, with this highlighted, you should have a default value. If you don't have this part fillable yet, you need to do a compile, because while you can add the variable, it doesn't let you set a default version of that variable until you've compiled it at least once. And then you can come back into your Blackboard. If you don't want to type it, select your entry name for your key, and then cut and paste or copy and paste that into that default value. All good?
Yeah.
Cool. Any other questions? Perfect. So now we have in our BP enemy base, right? We've now set the A controller class to the enemy base. And now in our event graph, we can actually delete our chase player. So much work. You could just disconnect it if you don't want it to delete it, but I'm just get out of here. And then we can remove our call to the chase player from our event begin play. And so now if we compile and save, right? So we have nothing in our code that should allow the AI to chase us. But if we go back and play, where is my AI?
Oh wait. You did it for a second. Oh, there you go.
Maybe.
Now it's chasing.
Yeah, something happened to mine. All my stuff from last week, for the most part, disappeared. That's great. It's fine. Everything is fine.
Well, yeah, it's working on my end, but it's not shooting. So, I guess I'm getting.
Yeah, we'll get to that part. So it should be following you. Mine is not. I'm not sure why. We're going to leave it for the moment. Save. Everything should be. Oh, it's probably because I don't have this saved. If yours isn't working, go ahead and make sure everything is saved for your Blackboard and your behavior tree. That's probably. My guy just wants to hang out. That's fine. We'll deal with him later. We'll keep chugging through this. All right. So we can add some more functionality to this behavior tree. So if we go back to our behavior tree, we can drag off from our sequence, await, task. We can switch this to the 2 seconds. This is kind of like what we had done before, right? Move to the player. Once you're in range, stop. Wait for a couple seconds, and then truck through if you do. But then, right, we added in an attack function. So we don't currently have it being able to attack us. So let's go ahead and create a custom task. So inside our AI folder, we're going to go ahead and create a new folder. We're going to call it tasks. That way all of our tasks can just be in one spot. And then back with the task folder, so now back in our behavior tree, we have the ability to make a new Blackboard if we needed a new Blackboard. We new tasks, a new decorator, which we'll get to decorators in a bit, a new service. We're going to do a new task. So click on new task. We'll double click on our tasks folder. So that says where we're going to put it. And then we can change the name. We'll leave it BTT. And we'll call this one base attack. And save. All right. And so now with that base attack, it automatically opens it to the event graph, which is great. When we have a task, there are 2 super important things that you need to do. Every time you create a task, I highly recommend just before you do anything else, add these 2 nodes to it. The first one is going to be an event receive execute AI. And then we're going to also add finish execute. And then for the most part, you're going to want to automatically set success to true. So if we don't have these, the task is never going to start. If without the event one, right, there's no task going to happen. If we don't have the finish execute, it will stay here forever. You will just be caught in an endless loop of this, or it's going to be like, well, I finished, and you didn't tell me I'm done, so I'm just going to take a fucking nap. It's fine. Don't worry about it. All is fine and good. I'll think about paying attention to you never. So with these two, right, we're always going to use them. I'll preface always with a big old asterisk. I'm sure there's a few situations where you're not. The majority of the time you're going to. So it's just easy. Pop them in there. Honestly, I don't understand why, if you're doing this, they don't just auto-populate with these two in there, but, you know, that'd be way too easy. Okay. Since we have our attack code already set up in our BP enemy base, we can drag out from the controlled pawn. So controlled pawn is the pawn that's being possessed. So we can drag off of this a cast to BP enemy base, right? We want to go and access the information we have there. And then from as BP enemy base, we can drag off attack, which is going to call the attack function / event that's going on in there. And now we just go ahead and finish execute. We can compile and save. And then when you go to now your behavior tree, we can actually drag off from here, and you'll notice in your tasks, we now have access to BTT base attack, right? Remembering that sequence is an order of events from left to right. So in this sequence, we have our move to target, right? Figure out who it is, move to them. Then once you've gotten to within the acceptable range, attack, wait 2 seconds, do it all again. But we need to fix one thing before we move forward with this. So we'll save this for the moment. We'll go back to our BP enemy base. And so we're going to add an event dispatch to assist with our completion, right? We want to make sure that the task actually completes before we actually move forward, right? So what we're going to do is we're going to add event. Which one is it? Hold on. Base. That's where we are. Oh, that's right. Ha ha ha. We want to honor my blueprint here. We're going to add an event dispatch. So we'll click on the plus there. We'll call it on base attack end. On base attack end. Then we can drag that out to our event graph. We'll select the call version of this. And so then I'll move this up. Right, so when we do our task of the event, we're basically saying, hey, come over here and spawn that projectile. But we want to make sure that we are then doing it there. We're going to, real quick, in between, we're going to add a delay. We want to give enough time for that attack to happen, right? So this is just spawning a projectile, which is really quick and short, right? Quick, easy. If this was a full animated attack, you'd want to know how long that attack is to then set that delay to the length of the attack, right? And then once that delay is done, then we can call the on base attack ends. We'll compile and save. We're going to go back to our BTT base attack. And from our cast to base base enemy, we're going to want to drag off of the as BP enemy base. And we are going to assign our on base attack end. So the assigned version of this. This gives us lots of fun things. We're just gonna make some space for this. We'll change the name of our event here to finished attack. We're going to connect our bind attack to attack. And now we're going to connect our finish execute. We'll break this. Alt and clicking on the connector will take care of that. We'll do our finish execute when our attack is finished, right? We don't want to end that before. We'll connect bind event to cast and our attack. Make sure that this is not, yeah, we're good. And we want to make sure that our finished execute is set to true if you had not done so yet. All right, compile, save. We can return back to our behavior tree. Make sure this is all saved. We've got our BT base attack here. Save. And now we should, although mine's probably not going to do it, which is fine. I think there's some other things that just did not happen in this because apparently it didn't save appropriately. When you play it, you should have the same functionality as you had last week. So it should be able to follow you, should, when it gets within range of you, start attacking. Yeah? What is it doing?
He's fighting more rapidly.
Well, it works. It's that when he dies, he's still attacking.
We'll just have to, we'll add that. You need to we'll basically turn it off and,
What, like the is alive?
right, it should be in there. Yes. Yeah, 100%. One of the things though that you probably could do at this point would be to, hey, look, mine's guy's shooting. It's neat. If you're within range of it, you should be able to probably sneak up behind it and it not give a shit that you're no longer in front of it and it's still going to shoot in front. Not necessarily the correct behavior for an AI. I mean, I don't know. Maybe it makes sense in your game to have an AI like that. I'm sure that there are games that are like that. In this one, it doesn't really make sense. So let's go ahead and fix that. We're going to, yeah, you have issues. It's fine. We're going to go back to our behavior tree. We're going to do like we did before. Bless you. We're going to go and add a new task. Now that we have added our first task, it now asks us what you would kind of like to base this task off of. So we're going to base it off of the BT task underscore blueprint base. That just gives us a starting point. As we did before, double click on your tasks folder, and we're going to call this one BTT underscore target focus. Right, we want to focus on who our target is because we don't want them sneaking behind us and killing the enemy but from behind. So we'll go ahead and save that. Once again, it just drops us straight into our task, which is great. As we did last time, right? We're starting a task. You want to just go ahead and add in your execute or event. Receive execute AI and our finish execute, right? Always want to have those ones. As before, we want to make sure on our event finish execute that we set our success to true because we'd like it to actually finish. And then we're going to drag from, this time we're going to drag from the owner controller and type in set focus. There we go. I'm not sure why my typing didn't do it. We've got set focus. That's the one we want. So we want to add a new variable to this. Remember that the behavior tree tasks are only passing back and forth to the Blackboard keys. So we're going to add a new variable here. We're going to name it attack target key. Instead of a Boolean, we're going to go ahead and change it to a Blackboard key selector, right? Because we want this from our Blackboard. And then we want this to be editable. So we're going to pop open the eye so that we can edit it from outside. I'm going to just compile it real quick. That makes sure it's fully open, anything that we need to do to it. Then we'll drag our get target key and we'll select the get version. Drag off from here. This time we're going to get value as actor, right? Because we're looking for the player. The class of the player is the actor. So we're going to set that. And then we're going to connect the value return from the get Blackboard value as actor to the new focus, right? And then we want to make sure that we finish our execute. So set focus to finish execute. Compile, save. We can return to our behavior tree. And then right before we attack, or right before the AI attacks, so we can move our move target over just a little bit, we can drag off from the sequence, add our BTT target focus. Our sequence is getting huge, and that is perfectly good. Right, so now it should move to you. Right before it attacks you, it should look at you, and then it will wait 2 seconds before it would attack again. So what we want to do here with our BTT target focus, right? Like before, our attack target key is currently set to self actor, which is attacking itself, looking at itself. I'm not sure exactly what it would do if we left it, but we're going to change it. In that default, we're going to change it to the attack target, right? That's what we've set it up to be. That's what we're going to change it to. So now if we save this, what we can do as well, let me do one change here. If we go back to our target focus task, and we click on our attack target key variable, we can actually set a category. And so categories allow us to lump variables into groups. So it makes it really easy if we put all of kind of one type of variable together, it makes it really easy to find. So if we change our category here to keys, now you'll see that in our variables, we now have a keys category, which now contains the attack target keys, which is really nice and easy. So now whenever we're looking, oh, we're doing another thing that's got a Blackboard key. Now we're keeping them all together, right? So compile, save. And we need to make one more change to our blueprint enemy base. We want it to actually focus. We've told it to focus. We just haven't finished saying it yet, right? Its focus is on the player, but we haven't said to rotate, right? It's like, I see you. I totally see. I know you're behind me now, but I can't do anything about it, right? We need to rotate. So let's do that. We can, off of our character movement in our components, if we select character movement, we want to come over in our details and search for rotation. You just do rota. Currently selected should be orient rotation to movement, right? So that's then it facing where it's moving to, which is great. But if it's not moving somewhere, it's not rotating. And so what we want to do is go ahead and check the use controller desired rotation and uncheck the orient rotation to movement. Now, if we compile, save again, and we come in and test it, which mine probably will not be working. Oh, they're dead. They are going to constantly stare at you and shoot a whole hell of a lot better. Right, so no more sneaking behind it.
Well, yeah, he's moving, but he's not shooting.
Sure. As long as he's moving, we're good. It should be shooting, but I think we had that issue with the shooting for yours, so we still have to figure that one out. I'm still not sure why that is the way it was. We'll take a look at that again today if we have time.
Quick question.
Yes.
So when I was looking through the tasks, I found there's a built-in task rotate to face EV entry. It's like if you're just like dragged out in the sequence and
Yep.
you could like rotate to base. Is there a reason we're not using that or
I'm gonna go with no. I'm not sure 100%.
I'm gonna try it see if that's
Yeah,
something.
I think that would be definitely something to try. Um, it feels like, let's just look at it. So I'm gonna unhook this. You want to obviously set your self actor to actor target. What happens if we do that? It is not constantly tracking it.
No.
So it does rotate, but it's only doing that rotation at that moment versus kind of constantly following you. So this could work in certain situations. Great question. And now we know. And like G.I. Joe said, knowing is half the battle.
That is true.
All right.
Told me about G.I. Joe told me about the task. So
It's fair. All right. So this is great, right? Now if you mine won't do it because mine's not moving at the moment because of issues, which is great. It's fine. If you now leave the viewpoint or you leave the range of your AI, it's still going to follow you, which is great, but it's going to just be constantly staring at you. It's going to constantly be focused just on you, which could cause some really interesting movement strafing kind of problems, which once again, it depends upon how you're going for. In this case, we're just going to have him kind of put his head down and run towards you. So if we go back to our behavior tree, we're going to add a new task. Once again, from the blueprint base. We're going to put it in our tasks folder like we've done, and we'll call it BTT clear focus. Got to have that clear Zen mind, right? I don't need to focus on you anymore. Once again, as before, event, receive, execute AI, finished execute. So we've got those ready to go. Set finish execute to true. Now from our owner controller on our event, we're going to drag off clear focus. It is kind of nice. This is one of the things I do like about Unreal over Unity sometimes is that they have a lot of these nodes that just have a lot of quick functionality to them. You know, I type 3 words and now I can clear the focus. I still like hard coding, but it's fine. And now we can just add that to our finish execute. All right. Compile and save. We'll return to our behavior tree. And then right before our move to, we can add in front of this our clear focus. So if you're going to move, clear your focus, move to the target, then focus again on the target once you're in range, attack, keep your focus on the target until you decide to move again, and then clear it and do your run like normal. So if we save this, once again, mine's just not going to work, but that should now, if we play it, thin range, he's not going to come find me anyway. But when you move, and you should just stop staring directly at you while he's moving. All right. So that's cool, right? Yay, he like chases after you. Woo, that's what we did with just a few lines of code last time, like, right? Way more involved than what we had done last week. Which is fine, right? All of this is reusable, which is great. All these tasks, right? We can just plug them in as we need to as we're going through. But AI doesn't always just hunt you down and track you down. So we're going to go ahead and add a patrolling state to the AI at this point, because having it path and patrol is sometimes a really important thing to have. So we're going to, into our AI folder, we're going to right click, and we're going to do a blueprint class, and we want to add an actor as the parent class, and we're going to name this BP patrol underscore patrol route. All right, good. Still recording. But patrol route.
Patrol route.
Yep. We'll double click to open like we've done plenty of times. Yeah, just a plain actor. Blueprint class, actor. BP underscore patrol routes. We'll double click to open it. And so now into our components, we could have this be where the AI just like wanders around, has no specific patrol route, which I mean works. But we want it to actually follow a predefined path. But we don't want it to just be a linear A to B. We want to be able to maybe go around a tree, maybe go around a bush, maybe go around the fire. I don't know. Protect AI. AI lives matter. Maybe they don't, but it's fine. We're gonna let them believe so. So we're gonna go ahead and add a spline. We want to make sure it is just the spline, not the mesh, not the nav modifier, just the spline, which gives us this beautiful straight line, which is great. We're going to actually rename the spline. So if we click on the spline, we're going to rename it to patrol route. And then we're just going to compile, save this. And now if we go to our level, so this should be in your first playable level rather than in your start menu, and probably not yet into your house that you built, but we can bring it over here, and I'm going to drop in our BP patrol route onto our environment. We'll focus on it. You can see, too close. We have two little white nodes, square nodes on the ends, which is great. So if we hover over it, we can click on that node and we can move it, which is great. We also have the little drag bars, which, if I can get it, allow us to curve the path. It's not going to show up very well in this just because of the way it is. You can kind of see how now we have a curve to it. If we then click on our node, that end node, or spline, if I can get it, there we go. And we press Alt and hold Alt while we then have it, we actually drag off another section. So we can drag that one off. We can drag off another one to another position. Each one of these becomes little waypoints along the spline. we're going to have it come over here. And right, so now we can have this kind of cool figure 8-ish shape. And we'll just kind of come to give or take here. So now if I scroll up a little higher, right? Now we have a pathway that they're going to follow. This could come around more of this. We could have it do an actual figure 8, right? But it's going to come from, the idea behind this spline is that it's going from one point to another point following that actual path. All right. So now that you have a pathway that you like, that is good, or at least it's good enough for the moment. So now we have a route. Now we want to actually get our AI to move along the route, right? So if we go back to our BP patrol routes, which I have way too many tasks open at the moment. All right, come back here. Now we can go to the event graph of our BP patrol routes. We'll go ahead and delete all of our current events. We don't need any of these ones. We're going to add a custom event that we're going to call increment patrol route. Right, so the patrol route being a spline is made up of those different nodes. So for every one of those nodes is one portion of the pathway. Until it gets to, we want it to follow the path until it gets to the end of the path, realize that it's at the end, maybe wait for a moment or two, maybe just immediately walk back and then walk back along the path to the start. When it reaches the start, realize it's got there, being able to walk back and forth, constantly patrolling until something else would happen. All right, so we're going to, we've got that. So we need to create two variables. We need to, our first variable is going to be a patrol index. Right? Which node is it currently on? We're going to change this type from Boolean to an integer. And then we're going to create one additional variable. We're going to call it direction. Right? So the direction is going to be, is it moving forward or backwards along the path? Right? Is it going, which way is it going towards? We'll compile this. And then with our direction variable selected, if you come over to the details, we have a value range. And so we want to set our value range from -1 to 1. So if it's going backwards along the path, it'll be a -1. If it's going forward along the path, it's a 1. So it's going to know how it should increment our steps accordingly. All right, we're going to drag off our patrol index and select the set. And then we're going to also drag off a get version of patrol index. Control and drag allows you to just get the get. From our patrol index get, we're going to drag off. We can do add, or you can do a plus sign. We just want the operator version of it. So we want to add. And then we want to get our direction. So we can drag direction on, select get, and attach that to the second pin or parameter of our add. So whatever index we're currently on, we're going to add to that what the current direction is. So if we're going forward, we're incrementing up by 1. If we're going back towards the start of it, we're subtracting 1 from our current index. All right, we're going to then connect the results of this add to our set patrol index, right? We're now setting what the new index is. We'll connect increment and set, so they run there. From our set, we're going to run one of our favorites. We're going to do a branch. Everybody loves a good branch. From our set from our output of set, we're going to drag off an equals. So you can just do double equal for the equal operator. And then we're going to drag, we're going to drag patrol route from our components on. From patrol routes, we're going to drag off get number of spline points. Right, so our spline is made up of a series of points. We want to know how many points are there on that spline. Patrolling starts at spline 0. So we want to, let's see, drag. We're going to drag off our return value here. So spline starts at 0, right? So any array starts at 0 through, right? So we want to actually start this as -1 as we're going. So we're going to do a subtract. Once again, an operation. We're going to get the number of points. We're going to subtract 1 because once again it starts at 0. So we want this to get the true number, we need to actually subtract 1 to find out at what point number our end is, right? We'll connect this one to our equals, or subtract to our equals, and our equals to our branch. So what we're checking with this when we get to our branch is basically, have we reached the end of our branch or the end of our spline? Is the node that we're at currently the last node that's there? And then if it is, obviously we'll want to turn around. So if it's true, we can actually do direct drag or direction off and get a set. We'll connect that to true. And we're going to set this direction to -1. Right? Our direction 1 means move forward along the path. Direction -1 means go back to the beginning. So if we've reached the end, go the hell back. Then if false, we're going to add another one of our favorite branches. We're going to drag off. We want to get, we can use, we'll just do it here. We're going to get our patrol index. So we'll get that. We're going to drag off an equals again. This one will leave at 0, right? 0 is where our spline starts. That's the first point. So if we reach 0 going backwards, then we need to turn around and go back the same way we came. And we'll just connect this result to our branch. And so what we'll do, I'm just going to click on my set. I'm going to Control D to duplicate so we get the same set. Connect it to true, but then change the direction to 1 instead of -1. So we're just flip-flopping back and forth to increment the correct way, whether we're walking from the start to the end or the end to the start. All right. Now we are going to just add a function. We're going to, in our functions here, right under my blueprint, we'll click on the functions, we'll click add. We're going to name this one get spline point as world position, right? We can't send the AI to the point unless we know where the point actually is, right? So we need to get that position. So we're going to drag off let's see, return. So if you type return, we have this add return node. So we're going to do that. In the return node, in our details for it, we're going to add an output. And so we'll click on the plus on output. We're going to change the parameter to location. And for the type, it's not obviously a Boolean. It's going to be a vector. So now we have X, Y, and Z. We're going to, once again, like we've done before, we're going to get our patrol routes. We're going to drag that on. We're going to drag off of the patrol route. And then we're going to get location at spline point. So where is the location of that spline point? We want to get a reference to the current patrol index. So we'll get our patrol index. We'll add that to our point index, right? So that's saying, well, this is the next point we're going to. And we're going to set our coordinate space, right? So we named this get spline point as world position. So we don't want local space. We want to switch this to world space. And then we're just going to connect the return value to our return node. So that is going to get us that destination for that specific point. We'll compile, we'll save. And now we want to assign the patrol route to our AI. So we're going to go back to our BP enemy base. We're going to go ahead and add a variable. So we'll click on our plus. Our variable is going to be patrol route. We're going to actually set its category to AI, which should be here somewhere. Let's try artificial. No. Where are you?
Do we need to create it somewhere else?
We shouldn't. Let me. Sure, it says category to AI. Let me try here. Oh, I'm tired. So in the details, we want to set its category to AI, not its variable type. So this is going to, once again, like we've done before with our keys variable category, we want to do the same thing with here. We're going to put this in our AI category so that keeps them together. We're going to now set the type. Variable type is going to actually be BP underscore patrol route. Really kind of weird that you can have a blueprint as a variable type, but hey, welcome to Unreal. We play how we want to play. And then we're going to open up the eye to make it editable, not edible. We don't need to eat patrol routes. It's fine. Don't worry about it. Compile and save. That can be the new like GIM treat is edible patrol routes. Okay. So we got those in place. We're going to go back to our level. We're going to select our AI, our BP enemy base AI that we've got in the scene. We're going to come down to our details and we're going to search for patrol, which should now be in the category AI. Did you compile and save?
Yes.
Do you, if you type in PATR, do you get anything?
I found it.
Do you have all selected? On the enemy base. So on enemy base, type patrol or start typing patrol. Because we set our category to AI, it should be under an AI category. We have our patrol route. Where are we at? So we can do one of two things with this. We can attempt to drag our patrol route into there, which is tricky. We can come here and click our patrol route, or we can actually use our eyedropper and select our patrol route, which of course did not work. It's fine. We'll just select it. It's fine. Everything's great. So now we are saying to the AI, your patrol route is this patrol route. So we could have maybe 5 different patrol routes, and maybe one of them is a patrol route that only gets triggered under certain situations. And so we can then assign that patrol route to the enemy to move it around the scene if we need to, right? Okay. Got that. Now we need to add our patrol route to our behavior tree. So we're going to go back to our behavior tree. Surprise, surprise, we're going to create a new task. Once again to the blueprint base. We're going to throw it in our task folder. We're going to name it BTT underscore move along patrol route. Save that. It pops up in the event graph. Remember to automatically add our event, receive, execute AI, and our finish execute. Set to success to true. All right, so we've got this prepped and ready to go, but we're going to pause for a moment because we want to be able to reuse as many of these blueprints as possible, right? We don't want to redo this every damn time that we want to do a new pathing on a spline, right? That just seems way too much work. So let's pause for a moment. We can compile if you want. It doesn't matter. If we come back to our AI folder, we're going to right click. We're going to actually come up and search for blueprint interface. And we're going to name it BPI for blueprint interface underscore enemy AI. So if you right click into the AI folder, you can type into that top search bar and it's blueprint interface. Perfect. We are going to double click on our blueprint interface.
Does it need a name?
BPI enemy underscore enemy AI. Should be here. So blueprint interface is basically a collection of function definitions that we can assign to any actor or class. And it's going to tell that class what functions it should assign, right? So we're going to say, okay, for this type of class, here are all the functions that you should have access to. It makes it quick and easy for what we want to do. So we're going to tell our AI what we want to automatically assign itself to. So we'll go ahead and change. We get a first function. It says new function. We're going to change this to get patrol route. And we're going to go ahead and give it an output. So we're going to hit the plus on output. Name the output parameter patrol route. And as we done before, we're going to give it the type BP underscore patrol routes. And we're going to get the object reference version of it. So now we've said, if you have this interface on it, anything that has this interface, you're just automatically going to always get the patrol route. You are a patroller. Merry Christmas. We're going to compile save. Back in our BP enemy base, we're going to go ahead and now up here in our nav bar, right, basically smack dab in the middle is class settings. We're going to click on that. And then details, under interfaces, we have where it says add, we're going to add our BPI enemy AI. So we're automatically saying, hey, you are an enemy base class. You will forever grab the patrol function. That's your job. Merry Christmas. That's what you get. Apparently I'm ready for Christmas. Perfect. We are then going to compile and save our enemy base. We should have now, minimize that. If you minimize your variables, you should now have an interface on your blueprints. So now attached to that, we have our get patrol routes. So if we now double click on our get patrol routes interface, we have the get patrol route and a return node. We need We'll open up our variables in the My Blueprint so that we have it, which gives us our reference under the AI patrol route. We'll get a reference to it, and surprise, surprise, we'll connect that to our patrol route in the return node. That's all we need to do with that, which is great. We can compile and save. So now what we can do, we can come in back in our event graph. No, where are we? Is it here? No, it's not here. Pause as brain attempts to catch up. There's something we can simply. We don't have controlled pawn. Where is my? Here we go. Ha ha ha. So if we go back to our what we had started, our move along the patrol route task, right? So now we can, from our controlled pawn, we can just get patrol route message. So as long as we have inheritance from the control pawn AI, we're going to get this route information automatically. We can then drag off of our patrol routes. We want to check is valid, the question mark one. From our if is valid, we can get spline. Hold on a moment. No, sorry. From our patrol route, we're going to double drag off of this because we can do multiples. We're going to get spline point as world. Hold on a minute. Control pawn, that's right. Get pawn routes. Drag patrol route is valid. I'm just going to hope I type this wrong. Get spline point as world position. I typed location, but I'm going to trust that I'm right. We're going to attach this to the is valid. I did type it wrong because now I have it right here. So then from our world position, we're going to drag off AI move to, which we've seen before. We're going to pass the location to the destination. The pawn, we can connect to the controlled pawn back on our events. We'll set our acceptance radius to 10. From get patrol. Once again, from our get patrol route, we're going to drag again from patrol route to increment patrol route. default of that. And we're going to attach this to both the on success and to the on fail. So we want it to just, no matter what, whether it makes it or it doesn't, we want it to just increment. Go to the next one. And then finish with our finish execute. All right, compile save. How are we doing? Ooh. Yikes. We're going to try and get through this today. Back to our behavior tree. So we've got our one sequence, which is here, which is great, right? This is find the player, attack the player, shoot the player, yay, win. That's great, but that doesn't really allow us for the patrolling. So we're going to actually drag off of the root another sequence. And we're going to call this, instead of sequence, we're going to change the node name to passive state. Should spell passive right. Still can't spell passive right. Close enough. Right, so when it's not actively attacking the player, you should just be patrolling. So we're going to, from this sequence, add our BTT move along patrol route. And then we'll just add, for right now, a wait. Just change it to a second instead of 5. And so every time it gets to the next point of that pathway, it's going to pause for a moment before it moves to the next one. All right, compile or save everything. Make sure it's all saved. We can come back and we should, when we hit play, please, hit play. Mine's not going to move because I have issues, but it should be now walking along the path that you created. Yes? No? Yours is. I know mine is having an issue just because it didn't apparently save right. No. It should. For this, you kind of don't want it to. It's, maybe a meandering path, but it goes along this to there to then back. Okay. We'll take a look. Do we at least have a few that are working? Cool. Yay. We're gonna keep trucking on because we've got a bunch to cover. I will post these notes for everybody tonight as well, along with the video. Okay. Got all that. But you should see, though, depending upon the length between your points, that your AI is probably like walking real fast and then like slows down and then gets there and like chills and then walks real fast and then slows up, right? That's not normally how people walk. I mean, it's, okay, I walk that way sometimes, but I have kids, right? So we don't really want to go that way. So what we can do actually in our BP enemy base, if we go to our character movement, click on that, and then under the nav movement, let's see if we can. I'm just going to start typing nav movement. Brings it there. We can uncheck the box of use fixed braking distance for paths. So the fixed braking distance is then like, right, oh, you're this distance from it, maybe you should start slowing up, right? That's where we're going to stop. Eventually, we're going to get this to where it just kind of walks along. It's not going to stop. But with this, we can remove that aspect of it. And if we then, so we compile and save this. And if we go back to our behavior tree and delete the weight, now with this saved, it should now move a much smoother pathway along. It's still not perfect. We're not there yet, but we're getting closer. All right. So if we go back to our blueprint interface, BPI enemy AI, we're going to add a new function. And we're going to call the function set movement speed. So while we could easily just give this a new input, give it a speed and a value, right? We just say, this is your movement speed. You're going to be moving at 100 and you're walking, or 200 you're jogging, 300 maybe you're sprinting, right? We're just changing that at one point. What we actually are going to do is we're going to play with an enumerator or an enum. And enum is basically a data type that allows you to define a set of name constraints that then we can assign values to. So we're going to go back. We're going to compile this and save it for the moment. We're going to go back to our third person map, to our content browser. We're going to go to our AI folder. We're going to right click and create a new folder and call it enums. If you're crazy, call it yum yums. I don't know. Fill it with Cheez-Its. Marcus, does that sound good? Okay, shame. Probably. This is what 4 hours of sleep will do you in trying to teach. So we got enums. We're going to then right click. We're going to search for enumeration. We'll select it and we'll call it E underscore movement speed. We'll open that. And what's great, we just add an enumerator, right? So we're going to add 4 of them. 1, 2, 3, 4. We'll name the first one idle. We'll name the second one walking. Third one jogging. Maybe. And the last one sprinting. Right, so those are, we could add more. We could add a fast walk. We could add just a nice slow, casually walk, whatever we want. We're going to stick with these ones. We'll save it. This is all we need to do. We'll save and close it. And then back in our BPI enemy AI, from our set movement speed, now we're going to add an input. We're going to call it speed for the parameter. And we're going to set its type to, if you look, we have enum. And we have our E movement speed. And then we're going to, which now, as you can see, we have a speed here. Now we're going to do an output. We'll name it speed value. Value. And now we'll give it a type of a float. Right, so we're getting the named item off our enum list, and we're going to assign those an actual float speed. So now we can then just say, hey, walking or sprinting. We can easily move between those and not have to reset a value every time, which is what we're getting to. So we'll compile and save our BPI, our interface. In our BP enemy base, we'll now double click on, we have our interfaces, right? Since we just created a new interface, we can now double click on our set movement speed, which brings in our set and our return. We're going to drag a reference to character movement onto our graph. We're going to drag off of this set max walk speed. We're going to let's see, we're going to connect our return node to set. We're going to basically do that, connect the set in between the returns. And then we're going to value, and then we'll connect our value across to the return node. And then our set max walk speed. Where are we at this? Connect, turn that. That's fine. Set movement speed to set max walk speed. We're going to drag off. Let's see if we drag off this. Wow, hold on a minute. We got our character movement. Yes. We drag off set max walk speed. We connected our return node to set max walk speed, execute, and that. That's great. Here we go. We need to hear from our speed, set it. Where are you? No, it does need to change data types.
There's a method to change it from a byte
From
to a
set
float.
max
However,
walk
it's gonna
speed.
do it right.
From max walk speed. Supposed to have. Let me try this real quick. That is not what I want.
Statement to set a different walk speed based off of the.
Set. We're supposed to get a. This doesn't make sense. Hold. Connect the set. Return that. That is fine. We are good with that. Connect set movement speed to set max walk speed. Did I? Hold on a second. Let me. This is a float. That's right. Drag off from max walk speed. Why are we doing this? That's all correct. I need to remember to start taking snapshots of my blueprints rather than just making word notes. Made sense to me on Monday. Making sense now? Not so much. Let's see. We got our reference to character movement. That's fine. Correct. We drug off set max walk speed. That is correct. We connected the return node to set max walk speed. Yes. Both execute and return value. Yes. Connect set movement speed. Set movement speed. Why is that now not? Let me just try set max. What value are you trying? Hold on. Set movement speed. The inputs. The output is a float. That is correct. The input. We did that. We did that. We did that. We added an input. We called it speed. That is correct. We gave it the type. The movement speed. That is correct. Single is correct. We have an output. We called it speed value. That's correct. Float. That's correct. We returned to BP enemy base. Let's see. Set movement speed. That's where we are. We've got that. We got that. We got that. For some reason, this is not connecting to that. That's fabulous. Yeah.
Try the select mode.
Let's try that. That's fabulous. Why?
And then plug the return value into max walk speed.
Perfect. Thank you. You read my notes and actually understood them. I have select there, but I took select as I have to select something. Notes, they're fabulous. I love coding. I know exactly what I'm getting into. Perfect. Thank you again. So from the set movement speed, we've got speed. We drag off to a select. So we have, since it's an enum, we want to select something from the list, right? So we have to say what the list is. Then we set that value, right? Select to that. And now what we can do here is we say, cool, isn't this neat? We can set idle to leave it at 0, walking to 100, jogging to 200, and sprinting to 300 because we're crazy, right? So now we have it set there. Now all we have to do is set this. Yes?
Pretty sure the starting walk speed is 500.
Is it 500?
Yeah.
We can't walk that fast. That's just too much. So yeah, so let's do, we'll do sprinting 500. Let's then bump up our jogging to 300. We'll leave walking at 100 and idle at 0. All right. We'll compile and save. Now into our behavior tree. We want to into our passive state, but before our moving along the patrol route, right, we first are going to take off. We need a new task because this is the only annoying thing, honestly, with creating behavior trees is the amount of tasks that you have to create, right? Thank God we can reuse them over and over and over again, but every single little thing is a task. And you really want to break it down into its smallest bite-sized pieces so that you can more easily reuse it. So surprise, surprise, we're going to create a new task off of our blueprint base into our tasks folder. We're going to go ahead and name it BTT set movement speed like we always do. We want to event receive execute AI and final or finish executes. Set it to true. From our controlled pawn, right? That's the one we're possessing. We're going to call out to the set movement speed message. And from here, it's great, right? We've got speed, idle, walking, jogging, sprinting. So now instead of entering a value, we just can set what we want it to be, which is great. So we're going to, I've gotten ahead of myself. Surprise. Connect. Set movement speed to our finish execute. And then we're going to promote speed to a variable. We'll call it movement speed. We're going to open the eye so it's edible. I think this is what I'm going to stick with at the moment. We'll compile and save. Back to the behavior tree. Now we can add our task, movement speed, all right, and then we can set our movement speed here. Default speed, let's just put it to walking, right? When it's going to into its passive state, walking along its pathway, it's just going to walk. We don't need it to run. And then in our chasing the player, right? So we have our sequence that's the chase and attack the player. So we can drag off from this sequence, add, once again, this is why it's nice, right? We can reuse it. We're going to set the movement speed. But if we're chasing, then we want to sprint. We want to go after the player as fast as possible. Save it. I would test mine, but I'm not going to see the difference. But if you test yours, it should just take a nice slow walking to when it gets to the path, walk through it, and then we're there. All right. Can we make it through the last couple pages? Probably not. We're going to try. Okay. We're going to blow through this a bit. So the last thing that we want to do, we're going to, well, not the last thing, but one of the last things we want to do is we want to set it up if the AI, for whatever reason, doesn't have a pathway, right? If it doesn't have a patrol path, we don't want it to patrol because it doesn't have one, right? So what we can do actually in this is what we'll use is called a decorator. They decorate the pieces, the different parts of the behavior tree, and it's basically an if statement, right? If this is actually true, then do it. If it's not, then who gives a shit? Leave it alone. So we're going to click on a new decorator. As before, we'll click on the blueprint base version of it, the BT decorator blueprint base. We're going to create another folder, so we can just right click in here, new folder. We're going to call it decorators. We'll double click on decorators. And we'll call it BTD underscore has patrol route. Right? We want to verify that it actually has a patrol route. And so in here, we're going to come to our functions. And if you see, we have this drop down on override. We're going to click on that, and we're going to do a perform conditions check AI. So the second one down, we're going to click on that. From the, give a little space. From the controlled pawn, we're going to get patrol route message. From to perform condition check AI. So we're going to connect it in the middle, or connect it to our condition check AI. From the patrol route on the get patrol route, we're going to check if it's valid, but we're going to use the other if valid. So instead, so is valid, instead of our question mark like we've been using before, we're going to use the function version of it. Is valid. We're going to connect the return value to our return node. And we'll connect our return node to get the patrol path. Pile, save. So this is going to, if there actually is something there, it's going to run it. If it's not there, we're not going to run it. So we compiled, we saved. We're going to go back to our behavior tree. We're going to move our root up a little bit. We're going to add a selector off of our root. We're going to connect the selector to our passive state. And then onto our passive state, if we right click, we have the ability to add a decorator. And so now we can do our BTD has patrol route decorator. And then we can, at the very end of our passive state, we're going to add a wait. So if it doesn't actually have a patrol route, it's just going to hang out until it apparently does, right? It's just going to be like, I don't have anything to do. I'm a patroller, but I have no patrol to do. All right. And so now we're going to change our selector. We're going to rename the selector here to passive state, even though we have passive state down there. Oh, sorry. Actually, instead of the weight here, we want the weight off of the passive state. Off the first passive state. So it's going to check and see if it's got the route, right? If it's got the route, great, do these things. If it doesn't have this, it's just now going to wait. And then we'll change this passive state to, I'm just going to change this one to patrol. Right, so this is what if you're in the passive state, you're either patrolling or you're just standing around doing nothing. All right, we'll save that. Okay, so now we have our attack sequence, right? Let's move that back up there. And we have our passive state. We can't connect both to the root, right? Root just goes to 1. So if we give a little bit more space again, we're going to go ahead and add another selector. Right, it's going to choose between one of these two. We're going to then be able to attack our attack. We can change this to actually to it. Attack. Why not? So we know it's happening. That's not how you spell attack. And then we can attack our passive state to the other side. So it's going to choose, if it has the choice, to attack first. If it can't attack, then it's going to move to the passive state. Perfect. We've got that now. We're going to save. To let us know what state the AI is in, we're going to actually add one more enumerator. So if we go back to our content browser, into our enumerator, our enums folder, we're going to search again for enumerator or enumeration. Select it. We'll call this E_AI states. Right, we want something that's going to set what those states are. So from this list, we could end up having 100 different states, right? This is going to keep track of them nice and easy. So we'll go ahead and open that. We're going to add 5 different enumerators here. The first one we'll just call passive. The next one we'll call it attacking. Maybe there's something where the enemy gets frozen for a moment, right? Or just is idle. So we have a frozen state, maybe some sort of investigating. We're going to set that one up. We'll deal with this next week, right? If maybe there's a sound and wants to go investigate what that sound was, maybe you just go over and check it out. And then we can have we have a dead state sort of already. We don't have a full state for it, but we've kind of set that up. As before, we'll just save. And we can close this because we don't need it. We now need to add states to our Blackboard because we now have values that are going to be attached to this. So if we go back to our behavior tree, we click on Blackboard. We're going to add a key. It's going to be the type enum or enumerator, and we're going to call it state. We're going to open up our key type dropdown. We're going to set the enum type to our EAI states, which is great. It just gives us the 2. All right, and then we're going to go, we'll save this. In our AIC enemy base, let's see, want to duplicate. Okay, where's my... So we'll just duplicate our Blackboard reference, Control D to duplicate. We're going to drag off set value as enum. From our enum value, we're going to set literal enum E_AI states. So we're literally calling directly to that states or that state. And we're going to go ahead and for our key name, we're going to promote that to a variable. We'll call it state key name. We'll compile. And once again, like we did before, from our Blackboard, we can get, hopefully you can spell state right. I'm tired enough. I do not trust myself. We're going to then bring that into our default value of the state key name, which is once again just state. And then we're going to connect our set value object to set value enum. Compile, save. We're going to, let's see. We can push through. We got this. All right. In our behavior tree, which is Blackboard currently, to behavior tree, we want to set up decorators to verify what state it's in. So we're going to click on our attack state, select add decorator, but this time we're going to select Blackboard instead of creating one. And this now allows us to check different keys that we set up in our Blackboard, which is great. So if we click on the decorator, set the Blackboard key. Let's see. Make sure the decorator is actually set. We want our key. Blackboard key. Here we go. Blackboard key set to state, which now gives us multiple. We want to leave it is equal to, and we set the value because this is attack to attacking, right? That would make sense. We'll do the same thing for our passive state. So right click on passive, add decorator Blackboard, click on our decorator, set the Blackboard key to state is equal to, and we'll leave that passive. All right. We are going to, can I get this done in 10 minutes? Maybe. We want to just be able to set our states. Actually, you know what? I'm going to, I think we can do it. We're going to try. Give it a shot. No, we're not. This has been enough, and my brain is now melted. So I'm going to finish this last little bit with a video, probably up. I need some sleep, so sometime tomorrow. So let's go ahead and save that. What we're going to do, the remainder of this video is basically going to be being able to just have a way for switching between the states. We don't have a built-in way yet, right? We haven't gotten into perception of our AI. We are just dealing with our AI from a standpoint of we still have most of the control over said AI. So what we're going to do with it, the remainder of this one is basically setting up a way to toggle back and forth between passive and attack, right? So you can have it walking along its control path and goes like, oh wait, there's somebody to attack. I'll run over attack, and then right when he gets you, like, nah, you should go patrol again. That was good. Right? So that's how we're going to set it up for this. That's the last bit of it. I believe that's where we get to. Yep, and then just a couple things that we'll use some of the pieces in this to make sure how it's facing, where its focus is, switching focus back to pathing, if it's moving from attacking you, right? Because we set the focus if it's attacking you to you. But then if you stop it at that point, it goes like, hey, I'm still I'm still looking at you. I'm gonna go do my path. So we need to be able to turn that off. So it's just gonna be some quality of life, little fixes at the end of that. Really, we have about 10 to 15 minutes, but the way my brain is working, it's probably about currently 3 or 4 hours. Just get those last 10 minutes to go. So thank you for putting up with today. I will make sure that this is up on there. At this point, start thinking about how you're going to want to now change this into something. Prove to me that you understand things that we've been working on. Add maybe some other basic simple AI. I'm good with that. It doesn't need to be behavior trees because those are a bite to take. Once again, you really are going to be diving into behavior trees when you're going to be able to reuse a lot of it over and over and over again, not just for one little thing. So feel free to create some of those, create some different pieces into it. Make sure to read through the Canvas description of what I'm looking for in the assignment. We're done with this. Now add 10 things, modify it, make it your own. Right, go through and change some skinning items. I know a few of you have kind of been doing this and have been going. So you're probably about done with that if you haven't, right? I do have a list of what qualifies. I don't want everybody to just be like, I added like 10 different objects to the game. It's different, yay! Like, it takes 5 minutes. So I do have categories in the Canvas, so please look those over. Come with questions for that next week. We are going to briefly dive into perception of the AI so that we can kind of control it based off of whether the enemy sees you or not. Make some decisions, or we'll also play hopefully with hearing you. And then that ends our third person parts. Is done next week, and then we move into first person. Begin starting to think about what you're going to be wanting to do for your final portion of the class, right? We haven't done first person yet, but start thinking, do I want to play more with this, or maybe as we're learning first person, maybe this is a little bit more interesting. There is no right way, you just have to choose one.
Or you can at least like do something more.
Yeah, the final portion of the class is to make your own game, either first person or third person, just a level, using what we've kind of gone over in class. Nothing crazy, nothing complicated. Seniors have a little bit special, different choices to make. Otherwise, have a great week. Be safe out there. It was shitty weather when I drove in. I don't know what it's like now.
Still great.
I'm gonna guess it's no better than what it was.
No, I'm saying if we had 7 characters, all different and elements. We did because the numbers, which is additional cost. What I'm saying is, you know, 7, so like 7 characters with different weapons and different elements are living the same version. Like, some person left, go on one, you know.
Oh, wow. Look who we have here.
Brain was just not connecting earlier. Shot it in drive. So that. That's okay.
I wish we did that.
I guess not good as you want.
Oh, this is Unity. No, not Unity. This is Unreal. Sorry. Like there's this like
Yeah.
Oh yeah, we had to do that. Yeah, but we did ours was not for something. Ours was for and then it was like it's all I got
So Unity,
So that's mine is basically literally, but I got to choose it. It's not like
buried down into your user stuff, it tracks.
what time is it? We have to go.
And you, oh shit, send all your info to that.
I'll be volleyball.
Yeah.
Okay. Good luck, guys. I will. Are you guys planning to take me next semester? Yeah. Okay. Yeah.
The other thing I'm gonna try to actually cover.
Might get it right.
Yeah.
Yeah, you're in the lab.
If you don't find anything, I know they're hot.
Yeah.
Oh,
Why
yeah.
you're able to drop it.
Even well, because I'm loading it,
Yep.
that's why I got to drop my good class.
It
Good
was,
to see you guys anymore.
I know it's not like super sensitive here, but like.
No, yeah, I'm always the opposite.
Stuff like that.
We only get to see
What,
because
Yeah. Well, because like JoJo.
same for JoJo, but the only one I've upgraded is at 300, but I don't have to watch it.
Yeah, I'm actually not picking it last.
So fun.
That's why I'm stuck in 200.
Yeah.
Because I skipped.
Yeah.
I did.
So,
It's fine.
So it sounded like
The new kids are
yes.
interesting. But
Oh.
no,
Well,
it's fine.
how much time at the end of the semester towards finishing the first person stuff will we have? Do we work on that or do
So
we
you
just
get full third of this.
Okay, because I was just
Or
trying,
more.
I was just trying to think like, because I know we're still doing the first two, so do we need to like be working on this already?
No, there should be enough time. I mean, obviously it depends on how depth you want to go with it.
Okay, I have an idea of what I want to do, so I just started looking at.
Yeah, if you already have an idea, I would drop. There should be plenty of time.
It's only because what I want to do is already like different questions. Sure.
Yeah.
I also wanted to ask if you could just real quick, there's one thing I missed, if I could just get a picture of it.
Yeah.
It was under enemy base. I was struggling to find where the inherited functions went.
Okay.
And once I found them, you had moved far enough in the video.